Welcome to the Shape of Probability. This video will explore the Gaussian distribution and its use in synthetic data generation, focusing on the core variables and mathematical formulas. When generating data, we move from the uniform generator, where all values have equal probability, to the Gaussian generator, where values cluster around a central point, mirroring natural distribution. The normal distribution is defined by two key parameters: the mean, denoted by mu, which is the center of gravity, and the standard deviation, sigma, which measures data dispersion. The 68959.7 empirical rule is a universal law. It states that 68% of all generated values fall within one standard deviation, 95% within two, and 99.7% within three. Advanced diagnostics include skewness, which measures asymmetry. A negative skew is left-tailed, while a positive skew is right-tailed. Kurtosis measures the extreme tail weight. Real-world phenomena like human height and IQ scores perfectly mirror the Gaussian mathematical model. These real-world baselines are critical for high-fidelity simulations. To generate synthetic data, we input the center vector, which includes the mean and standard deviation, the volume or count of data points, and the required precision or decimal places. The random seed is essential for chaos control. An empty seed generates true randomness. A locked seed ensures deterministic reproducibility, which is vital for scientific research and automated testing. The Box-Muller Transform is the engine under the hood. It takes two uniform inputs, applies a complex mathematical transformation, and then scales and shifts the result to match your parameters. Gaussian data has a broad application ecosystem. It is used in machine learning for initializing neural network weights, powering simulations, quality control, and statistical validation. By mastering the Gaussian distribution parameters, mean, standard deviation, and algorithmic transformation, you gain the precise tools needed to accurately simulate the complexities of the real world.